Thank you for that introduction, and thank you all for joining us live or on demand. My name is Alan Terletto. I'm the field CTO at Redis. Today, we'll talk about the unification of two of the most popular open source projects today. Of course, I'm talking about Redis and Trino. But that's not all. We're not just going to talk about it, we'll show it to you. And for that, I'm joined by my colleague, Julian Rowe. Julian will demonstrate how our new Redis connector for Trino can push down advanced queries and aggregations, which under the hood leverage Redis's unique in-memory secondary indexing. With this integration, Trino can return SQL result sets within milliseconds. No more scanning the entire Redis key space and make follow-on latency crushing operations over the network for each result. Now it's just a single operation at Redis speed. All of it completely transparent to users and seamless to integrate thanks to Trino. Julian's demonstration will be comprehensive, informative, and I think you'll enjoy it. So let's quickly set the table for him and dive right in. So why Redis? Why do we want our result sets back in milliseconds? And why now? Well, the world has changed. Pandemic lockdowns provided a preview of a digital-first economy and shortened expectations on when we will reach it by forcing everyone towards digital channels. Even more recently, we've seen hyper-popularity around generative AI, with its implications seemingly to have no end. So it's becoming clear that digital's impact on culture and business will only continue its acceleration. This means that organizations can no longer afford to deprioritizing modernizing the data tier, and rapidly evolving customer expectations by younger generations will continue to put pressure on enterprises to deliver a real-time user experience agnostic of the industry. In the digital-first economy, data is the lifeblood of the organization, which makes the databases the heart of enterprise architectures. By reinventing the customer journey across digital channels using cloud-native technology, enterprises will increase their business agility, customer experience, and be better prepared for whatever lies ahead. So now that we know where things are going, let's take a look at where we are today and what's blocking us from progressing forward. Most traditional architectures primarily still rely on a handful of legacy on-premise relational databases, even though most enterprise executives agree that legacy technologies have hampered their digital transformation success. So let's briefly dig into this paradox. Relational databases and mainframes originated during a period not only before the cloud was a viable idea, but storage, particularly RAM, was very expensive. With that as the constraint of the time, databases were optimized primarily with disk-based storage in mind, not performance nor data access. And the physical constraint of a spinning disk, which really hasn't improved much over the years, has limited performance across both latency and throughput. And that digital applications they desperately need and consumers expect. Fast forward to today's unprecedented demand for large-scale simultaneous access to real-time data, and it's no wonder we're seeing outages during volatile market peaks and hampered digital transformation efforts. However, this is where NoSQL databases shine. NoSQL databases were built using a 180-degree different mental model than relational databases. While relational databases optimize for storage first, NoSQL databases optimize for data access first. They were also built after the turn of the new century, when storage became increasingly cheap, including RAM, allowing for the viability of distributed data platforms to further drive down costs and set them up perfectly for the advent of managed services on the cloud. Now, of course, this is where Redis steps in, as it's perfectly suited for digital workloads. Redis is an open source, in-memory NoSQL database, which natively supports a variety of data structures and data models, each natively designed for a peak real-time performance and high-throughput use cases across transactional, operational, and analytical workloads. Redis gained its massive popularity by being the fastest data store in the market, with sub-millisecond performance, its ease of use, and as a multi-model database. Now, while I'm sure most of our audience has already heard about Redis, it's possible you might not have heard about Redis's advanced multi-model capability. Redis Stack consolidates models such as Redis JSON, time series, Bloom filters, and our unique SQL-like querying and search capability across secondary indexes into a single deployment. Redis Stack also packages our visualization platform called Redis Insight and our set of Redis clients called Redis OM or Redis Object Mappers, which are supported across major programming languages including Java, .NET, Node.js, and Python. This allows developers to have everything they would need to develop with Redis end-to-end with minimal installation and a frictionless user experience. Now, if you've never heard of Redis in the past, you might be asking how we can map relational tables to a key value database. So let's quickly touch on that in a general way, since there are different patterns depending on the use case. The most common approach starts with the key name. Using a colon as a common delimiter, we can name the key as a composition of the table name and the primary key, which makes it unique. Traditionally, a hash data structure would be used since it is effectively a dictionary of key value pairs, similar to the way we add on columns to a relational table. So for each column, you can add on a key value pair as a hash attribute. It's basically as simple as that, which is part of what drives popularity. It's ease of use. However, let's now apply this to a real-world use case, which will highlight a limitation. Imagine I needed to find all the employees that are principal engineers. I would need to create a separate key, which stores all employee keys with the role of principal engineers, or I would need to duplicate employee data into new keys so that the role is included in each key name for the purpose of being able to scan Redis to find them all. Now, while these solutions are utilized in production environments and they're feasible, they don't scale well in high throughput databases that have millions of Redis keys. So what can we do? Enter secondary indexing and Redis's SQL-like querying called Redis Search, which will be at the heart of our new integration with Trino and game-changing better performance at scale to the existing Redis Trino connector you might have used in the past. Redis Search enables querying secondary indexing and full-text search for Redis. It supports multi-field queries, aggregations, exact phrase matching, numeric filtering, geofiltering, and vector similarity semantic search on top of text queries. That's right, we have customers that are using this for vector similarity searches, but that is for another time. As you can see in these examples, this capability is far-reaching and powerful. However, for our purposes with Trino, we will only require its core capabilities of query support, including select statements across secondary indexes on both Redis hashes and JSON, aggregations such as count, min, max, average, ordering, and more. Now, by the way, that's right, I did say JSON. Just a moment ago, I showed you how to map a relational table to a hash data structure. However, that doesn't meet the needs of all use cases. For example, what if you were migrating from MongoDB? For this, Redis supports a native data model for JSON documents. It lets you store, update, and retrieve JSON values in a Redis database similar to any other Redis data type, and works seamlessly with Redis Search to allow you index and query JSON documents. Like hashes, this is supported for active-active deployments across multi-distributed clusters, so do give it a try if you have not already. So how does this impact Redis in terms of it being the fastest data store on the market? Well, rest assured, performance is not limited to only core Redis data structures and key value lookups. Even in benchmarks related to our JSON document model, latency and throughput are always first principles. In this public benchmark, you can see we perform 12 times better than MongoDB and ran away with it when compared to Elasticsearch. So what does this look like? Well, Julian will soon get into more detail, but just to level set, here is a quick comparison between traditional SQL syntax and the one supported by Redis Search. Now, I know what some of you are probably thinking. This is new, and it's one more thing that I'm going to need to learn. Or, more likely, you're thinking, how can I get this to integrate with my existing, let's say, Mulesoft application or visualization platform that does not support the Redis Search SQL-like syntax? Well, have no fear. This is where our new Redis Trino connector, as part of our family of Redis SQL connectors, is here to make things simple. Redis SQL Trino lets you easily integrate with visualization frameworks like Tableau and SuperSet, and platforms that support JDBC-compatible databases like Mulesoft. Query support includes everything we have already discussed, such as select statements across secondary indexes on both Redis hashes and JSON, aggregations, count, min, max, average, ordering, and more, because it's all based on Redis Search. That means you can run your Trino-compliant SQL queries and get response time in milliseconds, as if you were directly interfacing with Redis Search itself. The connector is open source and currently available on our public GitHub. Which reminds me, I have a first-time announcement. In collaboration with the amazing Trino developer relations team, we have decided to contribute this code to the Trino project directly, and will be available for support on Trino Slack channels, so stay tuned for more on this in the coming months. Let's now cover some ways that we've seen demand for this across the Redis user base. If you're not familiar, for example, lambda architectures aim to process data within parallel layers called batch and speed, or nowadays called streaming, and expose that data as an aggregated or materialized denormalized view via a serving layer. The serving layer views are typically queried for business intelligence, reporting, or nowadays predictive analytics in the form of feature stores and inferences for generative AI. Now let's take a step back though. When these architectures first became popular, at that time, there were much less technology choices than today. For example, Trino did not yet exist, and Redis was just beginning its journey to becoming the most popular database. As a point of reference, for example, back then the batch layer was typically Hadoop HDFS. For the serving layer, the choices were typically between Cassandra, MongoDB, Elasticsearch, or HBase. Now, if you're asking yourself, why would anyone use MongoDB for a job that's perfectly suited for a cache? Why wouldn't we use Redis, which is de facto caching solution instead? You're not alone. Well, for one thing, real-time analytics and real-time reporting were more of an aspiration than a reality 10 years ago. And the upstream interface for those architectures were in many cases third-party platforms such as Tableau or Power BI or MicroStrategy, which required an integration based on an industry standard such as JDBC or OLTP. So I bet you know where I'm going with this. Today, all these platforms are compliant with Trino's SQL support. And as we discussed, our new connector makes it seamless to integrate Trino with Redis Search, so you can get SQL query response at Redis speed and scale. With this, we can better address modern architectures that are driving digital innovation. Data meshes, data virtualization, lambda kappa architectures, online, offline feature stores, MLOps, AI data pipelines. It seems to go on and on. They all have the same need for serving an aggregated view of the data being processed as a stream or a batch or both. We can move on from legacy compromises, which should make Ryan Reynolds happy over there, without any dependency on learning the ins and outs of Redis' SQLite query language. Just configure, start Trino, and go, which is a perfect segue into our demonstration. Julian will show you how you can load data from some file system or relational database or data warehouse, and without writing a single line of code, query that data via a visualization platform such as Tableau, all at Redis speed. So without further ado, let me hand it over to Julian for this session's demo. Julian, floor is yours.
Thank you, Alan. Let's go through the Redis SQL Trino demo. So if you go to the GitHub repository that Alan highlighted during the presentation, you can follow the quick start in the README. In here, you'll see you can clone the repo. Excuse me. Clone the repo. Which I'll do here. And you go into the clone repository, and then you can start the Docker Compose instructions here. So Docker Compose up, which I'll run with sudo here. Okay, and what this does is start two containers. One for Redis SQL Trino, which is embedded inside a Trino distribution. And the other one is our Redis Stack environment. So it's going to be, like Alan described, it's going to be our Redis database with the search functionality. So we'll wait a few more seconds for this to be ready. And then in another terminal, I can show you the running containers. So here you go. We have the Redis SQL Trino container here and our Redis Stack server container on the other side. To make sure everything is running smooth, we can use the Redis CLI. Sorry. And it's available as part of the Redis Stack server distribution. So we can just run this command to get a peek into what's inside the Redis database. So if we do a keys star, you will see that we have some beers available. So this demo is centered around beers. So we can play with that data set, run some searches, and some SQL queries on top of that data set. So this is what we'll play with. So just to give you a overview of the data, let's look at beer number 213. And you'll see here that the beer has an ID. And by the way, this is Redis hashes, right? So Redis hashes are just key value pairs. So you can see we have these ID 213, brewery ID 779. So this is the number for the brewery for the specific beer. The beer has a name, in this case, Blackjack Porter. And it has a style, here porter, a category, which is like a super group for beers. In this case, it's an Irish ale. So we have around 200 beers here available to play with. I can show you that same data using Redis Insight. So I will connect to that database from Redis Insight, which is a UI for Redis. Let's go and connect to that data. You can see here the same data presented in a bit more user-friendly way. So let's look at beer number 14 here. You can see on the right side, the same key value pairs with different values. So ID is 14, brewery ID is 1099, the name is Imperial Stout, etc., etc. So all these are available in Redis, and we can search that data. So here we have, in Redis Insight, we have a way to query that data. So this is the indexing functionality that Alan described earlier. So if we want to see a beer containing a specific keyword, let's say Imperial, we just type that keyword here, and then Redis will return us all the beers that contain that word. So you can see the beer number 249 is an American style Imperial Stout. So we can query that data just by running keywords. We can also make it a bit more complicated, or a bit more complex, I should say, with a alcohol content. So this is a numeric field, ABV. I'm not sure what it stands for exactly, but basically it's the percentage of alcohol in the beer. So we'll do any beer between 5 and 10% of alcohol, right? If we run this, you'll see beer number 6 being returned. For example, here, the alcohol content is 5.2. Beer number 20 is 8.7. So all these fields are searchable or queryable using the indexing functionality from Redis Stack. So now we can use that data with Trino. So let me go back to that environment. And now instead of going to the Redis CLI, I'll use the Trino CLI to show you that data. So let's see the command. And again, this is all available in the repo. So if you follow the steps here, you can run that command to get the Trino CLI. I'll just paste it here. And here we are in the familiar Trino CLI, and we can look for the same data, but using SQL. So let's do a select star from beers. Beers is the table name again, AKA index name for our purposes. And if we do a select star from beers, you'll see the data set being returned by Trino. So beer number 1, name is Hocus Pocus. Alcohol content is 4.5%. And then there's a description and then more fields that we can see here, but all of them are available through SQL. And we can make a more complex query with that same data. So if I do a count, what this will do is do a query on Redis based on that SQL. So Redis SQL Trino will translate that SQL query into a Redis search query. So watch at the bottom, you will see the translation of that select count into the Redis search language. So what you see here when I did a select count is it's translated into an aggregation onto Redis search. You can see it's aggregating in the beers index, and it's doing a group by and a reduce with a count, which is exactly what we wanted to do here. We can do a more even a bit more complex query. Let's see if we can do select count from beers where ABV greater than 5, right? And we have the results here, which were returned by running this query onto the Redis search index. So here, in this case, we are doing a filtering based on the criteria, the SQL criteria that we had. So there's a direct translation between the SQL being used and the Redis search language. Okay, so now let's go back to our UI here, and then we will do the same kind of queries, but using Tableau. So I'll go to Tableau, and using the Presto, which is the older name of Trino, let's connect to our Trino container. So the parameters are going to be the host name, or the IP in this case, the port 8080, which is the default for Trino, and then the catalog that we're using is Redis search, and the schema is default. And we pass in a username in order to be able to sign into the data source. Here you go. We have a connection to the database, the Redis database. And for Tableau, it just appears as a traditional relational database. And here we can use our same beers index, and we will see the data, but this time from Tableau. So if we double click on the beers index, you'll see that the same data, the same fields are available for us to build dashboards with. So we still have our ID, the brewery ID, the name, the ABV, style name, category name, etc. So let's build a dashboard with that data. And again, Tableau thinks it's a RDBMS, right? It only knows SQL, and it will run these queries for us at the speed of Redis with the convenience of SQL. So let's grab the style name. What we want to do is basically group beers by style and see the difference in alcohol content across styles. So I'll use the style name, the average alcohol content across these beers, and I'll use the count. So I want to count how many beers there are in each style and group and see what the alcohol content is for that group. The default display or dashboard style in Tableau doesn't really reflect what we want to do. So we'll change that to bubbles, for example. And right away, you can see some styles have more beers than others. So American style pale ale seems to be the bigger group. The circle, the bubble is bigger. And indeed, it has 34 beers, as you can see here. And the average alcohol content for that style of beers is 3.3. Now, if we get to the next bigger style or more popular style, it's American style lager with 22 beers and an average alcohol content of 2.2 or 2.3. The colors that Tableau shows by default are not really the most intuitive. So let's change that to temperature diverging, which for me seems to be more, speaks more to me. So here, if we change the color style of the color palette, you'd see that towards the red end of the spectrum, the beers are stronger. So you see here, this small style group called Belgian style quadruple only has one beer, and that one beer has a 11.3 ABV. It's probably the stronger beer group in this data set. And then this orange one is probably pretty strong too. You can see 10% alcohol content. And then when you go towards the green end of the spectrum, you'll see lighter beers. So let's see traditional German style Bock. You can see there's 10 beers and an average alcohol content of 5.8. So here with Tableau, you can see that we are running at the speed of Redis, being able to build these dashboards very easily. And we just need to let Tableau do its magic. And the magic is powered by Trino in this case. We can change that style of dashboarding, and you can see that the same data can be visualized differently, again, in a very fast manner. All right, so again, if you want to run that demo and use that same data set, you can clone the repo, do Docker Compose up, and use the Trino CLI directly against the container and run these SQL queries. Thank you for attending, and I'll pass it back to Alan.
Thanks for that great demo, Julian. For the audience, if you're interested in what you saw and want to give it a spin, you can follow the instructions, as Julian said, on our GitHub README. For a quick way to spin up Redis Search, you can take advantage of Redis Cloud, the free tier, which uploads it with a simple configuration. On behalf of Julian, myself, and everyone at Redis, thank you for joining our session, and also thank you to our friends at Trino. We hope you enjoy the rest of the conference sessions and check out Redis SQL for yourselves. More to come. Cheers, everyone.